I'm going to go ahead and just review the first two sections of Unit 6 that we have done so far. Starting first with the Pythagorean theorem. So using the Pythagorean theorem, given the fact that we have a right triangle and we have a missing side that we need to find. So remember that your Pythagorean theorem is a squared plus b squared equals c squared, and c is always your hypotenuse. And to find your hypotenuse, it is the side across from the right angle. So this is your hypotenuse here. So a and b are interchangeable, so you just plug in your numbers. X squared plus 9 squared equals 15 squared. So we get x squared plus 81 equals 225. Subtract 81 from both sides of your equation to get x squared equals 144. Take the square root of both sides of your equation because the square and square root cancel, leaving you with x equals the square root of 144, which is 12. And since it came out to a perfect number, perfect whole number, we'll go ahead and write the answer as 12. All right, your second example here, so same thing, it's a right triangle. This is going to be your hypotenuse because it's across from your right angle. So a squared plus b squared equals c squared. We'll put in x squared plus 8 squared equals 10 squared. So x squared plus 64 equals 100. Subtract 64 from both sides to get x squared equals 36. Take the square root of both sides. And again, this comes out to a perfect square, and you get that the answer is 6. Now for your third example, so now we get a little bit more complicated because we've got, square roots already in there. So again, start with the fact that here's your hypotenuse across from your right angle. So a squared plus b squared equals c squared. X squared plus, and then this time we need to use parentheses around our number and square it, and do the same thing for your hypotenuse. And when you put this in the calculator, make sure that you put parentheses around this whole thing with the square on the outside, and make sure you do it for both. And when you do that, what you end up getting is 8 here, and on the other side you get 12. Now subtract 8 from both sides, and you will get x squared equals 4. Take the square root of both sides of your equation, and this time, again, it comes out to a perfect number, a whole number, so we get x is 2. Now in your fourth example, again, hypotenuse across from the right angle, so a squared plus b squared equals c squared. Plug in x squared plus 8 squared equals, and remember to use parentheses around your square root number here, your square root of 170. So we get x squared plus 64, and this you don't even need a calculator for because your square and your square root are opposites, so it's just 170. Subtract 64 from both sides of your equation to get x squared equals 106. Take the square root of both sides of your equation. So now what we end up getting, and I'm going to just write this over here because I'm out of room, you end up getting x equals the square root of 106. Now I would leave it like this, but you can change it to a decimal, so your other option would be to write it as x equals 10.3. Either one of those is acceptable. It doesn't matter which one you choose. All right, second type of example is just doing your converse of the Pythagorean theorem. So given these numbers, determine if they'll make a cute right or an obtuse triangle. So here are your three numbers. Now you have to know which one of these is your hypotenuse. So first thing you want to do is get the decimal form of this answer right here, of this number. So when I type this in the calculator, what I end up getting is it's about 13.7. So that means this number right here has to be your C because that's the biggest number. So when we plug it into our Pythagorean theorem, I'm actually going to put our C first, so 15 squared, and we're comparing it to 6 squared plus, and remember to put parentheses around the rest of your information here because we have a whole number and a square root. So we get 225, and then we get, a blank here, and then we get 36 plus 189. And so we get 225 over here as well as 225 here, and because it's equal, then this will be a right triangle. All right, moving on. Second example, so this one is your largest number, so that's going to be your c. Remember, c is always your largest. And so we're going to do c squared, and we're going to compare it to 12 squared plus 9 squared. 17 squared is 289, 12 squared is 144, 9 squared is 81. So we get 289 here, and over here we get 225. Well, in this case, this number is larger than 225, and because it's larger, that means it will be an obtuse triangle. So remember, you always want to do c squared, and then over here a squared plus b squared, and compare your information. All right, third example, this is your c because it's your largest number, so we'll do c squared and then a squared plus b squared. 13 squared is 169, 10 squared is 100, and then plus 144. 169 in comparison to adding those two together, which is 244. Well, in this case, 169 is less than, and because it's less than, this is an acute triangle. All right, and then our last example here, we have 10, 24, and 26. 26 is the largest, so that's your C. So 26 squared, and compare that to 10 squared plus 24 squared. So 26 squared, we get 676. 10 squared is 100. 24 squared is 576. And so we get 676 here, we get 676 here. Those are equal, so this is a right triangle. And there you go. All right, and then our last type of examples here that we have are using our special right triangles to find missing side lengths. And so setting up proportions is basically your main idea here. So given that this is a 45, 45, 90 right triangle, this is 45 here, we need to match up our sides. So square root of 2 is along the 45 and 90 side, so that's going to match up to 1 because it's along the same side. And then on the other side here we have a along our hypotenuse, and so that needs to match up with a, which is also the hypotenuse. So remember, hypotenuse is across from the right angle. So we're going to take the square root of 2 and put it over 1, and set that equal to a over the square root of 2. So when we do our cross multiplying, here we get a times 1, which is just a, and here we have two numbers that are under a square root, so we can leave the square root and multiply our two numbers to get 4, but the square root of 4 you can actually do because you get a whole number, and that would be 2. So then there's your answer. So remember to keep it consistent. So this top part right here, the whole top is from this triangle, and then the whole bottom portion is from this triangle. So you just have to keep it consistent. Now your second example, we actually have two different pieces of information to find. So you have to make sure that you match up your sides correctly. If this is your 60-degree angle, this would be your 30-degree angle. So let's go ahead and find n first. So n is alongside the 30, 90. So that's going to match up with the square root of 3 because it's along the 30 and 90. And then we're going to go with 10 times the square root of 3 over 3. That's alongside your 60 and 90, and that's going to match up with 1 because it's also along your 60 and 90 side. So we go to write our proportion. We'll put n over the square root of 3. And set that equal to 10 times the square root of 3 over 3. So that's your side here, and put that over 1. So when you do your cross multiplying, you get n equals, now here, 10 over 3 stays as it is, but under your square root, you can multiply this 3 by this 3 to get the square root of 9. Well, 10 times the square root of 9, we know that the square root of 9 is actually 3, so I'm going to replace that with the number 3. So we get n equals 30 over 3, which means that n equals 10, and there's your n. So now I'm going to get rid of that stuff so we can go ahead and find our m. So we're going to do the same type of thing, it's just we have to match it up with a different side, so we're writing a different proportion this time. So this side, m, is our hypotenuse. It's going to match up with that side right there. So we're going to take m and put it over 2 and set that equal to 10 times the square root of 3 over 3, and that's matched up to the side that's 1. Cross multiply to get m equals. Now when you cross multiply here, you only do 2 times the 10, and everything else stays as it is, and there's your answer. And you don't need to put it in decimal form, you can just leave it as it is. All right, next example. So given the fact that these are congruent sides, these legs are congruent, that would make this an isosceles triangle. So if it's isosceles, then what that means is that this angle is congruent to this angle. Well, if they are congruent and it's a right triangle, they each have to be 45 degrees. Okay? So given that they're each 45, we'll go ahead and match up our sides. So hypotenuse matches up to hypotenuse, and let's go ahead and just solve for x. X matches up to the side along 45 and 90, which is 1. So when you go to write your proportion, put x over 1 and set it equal to 4 over the square root of 2. So when you do your cross multiplying, you get x times the square root of 2 equals 4. Divide by the square root of 2 to get rid of that from your x. So you end up with x equals 4 divided by the square root of 2. Now, anytime you have your square root in your denominator, you need to divide it out. And so we'll go ahead and write that as 2.8. Now, you'll notice that x and y are marked as congruent because they're both the legs of a 45, 45, 90. And so for that reason, y would also be 2.8. Okay, one more example, so another 30, 60, 90. And so in this example here, we'll match up our sides. So starting with 7 over 2, that's between the 60 and 90, so that gets matched up with 1, which is between the 60 and 90. And then A, which is the hypotenuse, gets matched up with 2 because it's the hypotenuse. So we take A over 2 and set it equal to 7 over 2 and match that up with 1. We do our cross multiplying, so we get A equals, remember because 1 times A is just A, multiply here. Now remember you just do 2 times 7, which is 14, over 2. But always simplify, 14 divided by 2 is 7, and there's your A. All right, any questions? Just come in ready with them so we can go ahead and get this quiz started.